Hello, we are from Group 11. Our title is Smart Cities with IoT. First of all, I will introduce our group member, Anas bin Adnan, Muhammad Hanafi bin Muhtaduddin, and my name is Muhammad Farisindra bin Chandran. And especially our lecturer's name, Dr. Chiu Chang Chun. The introduction. First, smart cities are expected to improve daily life, promote sustainable development, and enhance the functionality of urban systems. Next, with the implementation of many smart systems, security and privacy issues have become a major challenge that necessitates effective countermeasure. Furthermore, when designing and implementing new mechanism or system, it is critical to be aware of security and privacy threats. Gathering their information is critical for day-to-day activity management and long-term development planning in the city. To that end, various technologies have been employed to address the unique characteristics of each application. The technologies required span a wide range and layering, from the physical to data and application layer. Our objective is to review the articles about smart cities application by implementing of Internet of Things (IoT). To summarize the layer architecture of smart city according to application network and sensor layer. To analyze the importance of applying the smart city in each country.
Hello, my name is Anas Badana and I will present about basic layer IoT architecture. Mainly we use three layer architecture, which is first is perception layer, which it include device such as sensor and controller that allow the existence. For the second is a network layer is used to broadcast and process data as well to connect various devices in the previous layer to server. And for the third is application layer, which is allow a specific service of different application, especially for smart city where smart parking. There are four stages process of building an IoT architecture where it include the first is a sensor and architecture. For the second is internet gateway and data aggregation system, which is where the data process. And the third is edge information technology, where the data is stored. And for the fourth is data center and cloud. For the perception or sensor device layer, it is the lowest layer of IoT architecture where it collects and preserves data and useful information from the things connected in the network with the help of connected device such as a sensor network, RFID or camera, GPS, and mobile phone sensing system. And in this layer, the sensor is a basic connection for the IoT system to deploy multiple services into a smart city. Perception layer capabilities can be categorized into two groups, which is first is device capability and the second is gateway capabilities. Where the device capability is include direct interaction such as collect data and upload collected data to the communication network. For the gateway capability is include multiple interface support from the sensor. Here the example of the sensor that's normally used in the smart city, which is accelerometer, proximity IR sensor, gas sensor, temperature sensor, chemical sensor, smoke sensor, and motion detection sensor. For the discussion, we differentiate IoT architecture that can be used to design the smart city, which is firstly is 4-layer IoT architecture, and for the second is 5-layer architecture, and for the third is 6-layer architecture. As you can see here, for the 4-layer IoT architecture is at the support layer where it focuses on the security after it with the password or authentication. For the 5 layer, two layer, which is middleware and business layer. Middleware is to store and process huge amount of data, and business is focused to the uh, owner profit. And for the seed layer, it add the observer layer, middleware layer, and security layer, where it combine with the security and the big data process in the system, IoT system. We also discussed the main issue with our proposed IoT architecture, which is three-layer architecture for the confidentiality, integrity, authentication, authorization, and the issue is okay. Thank you.
This is the various network protocol that are useful for smart city application. The, net, the network protocol is ZigBee, Bluetooth, Wi-Fi, WiMAX, cellular 3G, cellular 4G LTE, and satellite. Illustration of network layer in smart city application. First, smart grid system. Smart grid can use all network protocol except satellite because in the system as in figure 3, which is this figure, smart grid has device that form node in the mobile ad hoc network, MANET, or wireless sensor and actor network, WSAN. The node can communicate using multi-hop networking protocols specifically designed for MANET and WSAN. Typically, one of the node serves as a gateway connecting the network at that location to the infrastructure, LAN, LAN or the internet. Cloud computing platform can also be utilized to deliver smart grid network system storage, analysis, analysis, processing, and decision-making service. Next, we go smart water system. Using an efficient procedure, the system is utilized to monitor and manage the irrigation of the soil with various types of crops. Actor devices are used to control a variety of activities such as the amount of water given by the system and the time it takes to provide it. In a WSAN, both sensor and actor device are nodes. Mesh and star topologies are examples of possible node topologies. One of the node server one of the node service one of the node servers as a gateway connecting the sink to the backbone, LAN, or the internet. Storage, analysis, processing, and decision-making capabilities can all be provided via cloud computing platform. For second layer is network layer. In introduction network layer, the network layer is the foundation of the Internet of Things architecture, and it relies on basic network including the Internet, WSN, and communication network. This layer's job is to connect smart item, network device, and server by transmitting the data acquired by the perception layer. IoT systems use a combination of short-range network communication technologies such as Bluetooth and ZigBee, which are used to carry the information from perception device to a nearby gateway based on the capabilities of the communication parties.
For application layer, the application layer interface communicate with the application directly and provide common web application service. It is responsible for providing intelligent and practical services or applications to users based on their personalized requirement. The application layer protocol are MQP, messaging, queuing, telemetry, transport, QAP, Constraint Application Protocol, DDS, Data Distribution Service, AMQP, QMAP, else MQTT, QAP, and DDS are mostly used in smart city application because of capabilities of implement messaging techniques in form of published subscribe method, and provide QoS quality of service. The information sent from the server side is encapsulated in JSON object form. To send push notification, the system uses Google Firebase platform. For email notification, we use SMTP, Simple Mail Transfer Protocol, and for SMS notification, webs to SMS protocol is used. The mobile application is created using Android Studio IDE, integrated development environment, encoded using Java, Kotlin, and QML extensible markup language. IoT technologies for smart cities, addressing the ability of uniquely identifying devices and things is essential to achieving desirable IoT outcome. The reason for this and that exclusively addressing the large-scale mixture of things is critical for controlling them via the internet. Middleware, due to several concerns about the heterogeneity of contributing object limited storage and processability and the vast variety of application type middleware plays an important role in the interconnection of things to the application layer. Smart cities platform and standards. The relationship between physical and IT infrastructure create a novel machine-to-machine (M2M) communication for smart cities. Furthermore, this platform contribute to the formation of the IoT using real-world sensors and communication network. Actual IoT application for smart cities. Smart home. Smart home can be observed by utilizing data generated by various sensors. In fact, IoT technology leads to smart home and appliances such as smart TV, home security system, lighting control, fire detection, and temperature monitoring. Second, healthcare. Some of these applications include the tracking of people and objects such as patient, staff, and ambulance, the identification of people, and the automatic gathering and sensing of data. The status of patient in a clinic or hospital is monitored in terms of people and objective tracking to provide better and faster workflow in the hospital. And lastly, environment pollution. An urban IoT can be used to monitor air, air quality using outdoor sensors in places such as a river or parks. Moreover, communication facilities can be provided to access the quality of air, quality of water, and other parameters such as humidity, temperature, ambient carbon dioxide level, and other harmful gases, and pollution, ensure pollution is at the acceptable level.
For conclusion, we may conclude for this study that incorporating Internet of Things into smart city system is critical for current and future advancement. There are numerous benefits that customers may take advantage of when it comes to IoT smart city system. The notion of the notion of open system interconnect is a key concept that should be prioritized in the development of smart city IoT system, according to our research. Whereas the whereas the OSI model is a seven-layer conceptual framework that represents a network and telecommunication system, each with own function. Furthermore, each layer can assist network professionals in visualizing what is happening in their network and assisting their network in the event of physics or application-related problems. As a result, most manufacturers who develop new goods will constantly resort to the OSI model to explain how each layer of their product works to their consumer. For recommendation, energies must refer to the Open System Interconnect model in greater detail to build IoT-related products on smart city system as each layer share the advantage of components, device, application, network protocol, and so on. They can also concentrate on critical requirements like as routing, energy efficiency, security, reliability, mobility, and support for heterogeneous networks. As a result, they must perform more relevant research and study to build and create efficient network communication protocol, and architecture in order to meet the growing need for vital and rapidly growing smart city application and service.